So the next question is wildcard matching. Let's read the question. Given an input string S and a pattern P, implement wildcard matching with support of question mark and star, where question mark matches any single character, star matches any sequence of characters. The matching should cover the entire input string, not partial. Basically, we are given a pattern string and a string. The pattern string will contain along with some lowercase letters, it may contain question mark and star characters. The question mark will be replaced with a single character and star will be replaced with zero character or any number of characters. Okay, and the constraints are length of string S and P is around 2000. So a complexity like n cross m would surely be is equal to 4 into 10 power 6, 10 power 6, which is less than 10 power 8 would work fine here, or n cross m into log of n would also work, or n cross m into log of m would also work here, because log of 2000 is approximately, we can say, 12. So this particular into 12 is still less than 10 to the power 8, so solution like this would work fine. Let's say the n is length of string s and m is length of string p. Okay, so how we will proceed with this question? So the first thing that comes to our mind is any greedy strategy, if it will work or not. Has there been no star character, then greedy strategy would have worked. If we would have only question mark and lowercase letters being contained in string p, then a greedy strategy would have worked. But due to the presence of this star character, greedy strategy fails, because star character can contain zero character, it can consume zero character, one character, two character, or any number of characters from string s, and addition of this particular line hints us that greedy strategy won't work, and we need to try all possible sequence of operations in order to transform p to s. If any valid sequence of operations is possible, then return true, else return false. For example, let's consider this test case. We have p equals a and s equals double a. So a matches with a. Then we have another a character. Here we have no character. So string s will never be equal to string p. Hence answer is false. Here we have p as star and s as double a. So star can contain any number of characters. It can also contain these both characters. So here answer is true, since we can replace this star with double a. Again, let's analyze this test case. Here we can replace star with a single character, and greedily, obviously, we will replace question mark with c. So our string p becomes ca. Okay, ca, and here we have b. So cp is never equal to ca. Hence the answer is false. Okay, so here the question hints us towards a recursive idea, where we will consider all possible sequence of operations that we can perform on s in order to transform it into on p in order to transform it into s. So for performing all possible operations, what we can do? Basically, we need to handle some cases. For example, if somewhere s of I becomes equal to p of j, then what I will do is I will, for example, let's f of ij denotes if it is possible to transform string p to s. or not, or not if uh, if we consider string s from I to n minus 1 and p from j to n minus 1, this. Okay. Okay, if we encounter s of I equals p of j, then simply what I will do, our this recursive solution, that is recursive call f of ij, will be converted to I plus 1 and j plus 1. Simply here we have a recursive idea. Okay, and in recursion what we generally do, we have a bigger problem f of ij. So in recursion what I will do, I'm explaining it, f of I to n minus 1 j2, I'm considering string j to m minus 1. Okay, if this particular condition holds, s of I equals p of j, then what we will do, we will the f of I n minus 1 j m minus 1 get converted to f of, since these both characters are equal, so it is converted to I plus 1 to n minus 1 and j plus 1 to m minus 1. Similarly, if they are not equal but p of j is equal to question mark, then the same case, that is this particular case will if p of j is equal to question mark, then here there is only one case, that is replace question mark with the character present at the ith index of string s. Okay, for example, let's take an example. We have string s as aa as string s, and we have question mark a as string p. Then since a is not equal to question mark, and since we are having question mark, then the only possible option is to replace a question mark with a. So the bigger problem, f of I to n minus 1 j to n minus 1 breaks into f of I plus 1 to n minus 1 and j plus 1 to m minus 1. Okay, then again the last but not the least case comes, where p of j is equals star. In this case, the star can accommodate into it one character, two character, or any number of character, or also no character. Okay, so if I have my function call as this I to n minus 1 j to m minus 1, and I want key the star character is replaced with null character, means no character, then simply what I will do is I will keep it as n minus 1 and I will do here j plus 1. So basically you can see here that a bigger problem I to n minus 1 to j m minus 1 is being converted into this. How this happened, let me explain it by taking an example. String s as aa, this is string s, and I have string p as star a. Okay, this is string p. Here what I can do is I have here a, here star. I want that this particular star is being replaced with no zero character, there is no character, empty character. So what I will do, I will do simply j plus 1, pointer shifts here, and the I pointer is kept at its place. So in this case what I have done is I have replaced this particular star to null character. Okay, null character, or simply null is also a character, sorry, not null character, empty character. Okay, or we can have this case, this particular case, or we can have, if I wish to replace the star with only one character, then what I will do, I will do f of I plus 1, since I am replacing n minus 1 to, I have kept j to j plus 1 to m minus 1. In this case, what I am doing is the star is being replaced with only one character. And what is that character? That character is the ith character of string s. Okay, so I will show this particular thing in code. Okay, um, so let's proceed and see the code, recursive code, how the recursive idea is being implemented in code. I will explain nicely this particular thing. I will explain it nicely in the code section, and I will also explain this whole part uh, in code also. So let's move to code. I will pass 00 string s and string p. Okay, solve. I have int I have int j, string s, I have string p. Okay, I have initialized answer to 0, and if it happens that s of I is equal to p of j, then we have no other option than to do I plus 1 and j plus 1 and s and p. It n is equal to s dot size, m is equal to p dot size. Okay, if it is not the case, and if p of j is equal to star not question mark, then what I can do is I can set answer to, here also we have only one possible scenario, and then again if it happens that p of j is equal to star, then in this particular case what I can do is I can set answer to, I can set this star character to empty character, that is solve. If I set it to empty character, what I was doing here, I was doing I j plus 1, I j plus 1 sp. Now another important thing, since the question tells us that we can replace s with no character, which is handled here, or we can replace s with any number of characters. To uh, include this particular case that our star can contain one or more characters, I am including one more variable. I will explain how it works. I am setting it to started. Okay, what started denotes, started can take basically two values, 0 and 1. If started is 0, if started is 0, if started is 0, it simply means, if started is 0, it simply means that star has not started to consume characters from p, from s. Okay, now if started is equal to 1, it simply means that star has started to consume characters from s. Okay, so basically I need to add it here. I will explain how it works. So here I have used the star character by replacing star with empty character. So I have used it, and that's why I have set it as 0. Okay, now you will get it. Now you will get it. I told you that either I can replace it with a single character, with no character, which is handled in this line, or we can use star to uh, consume one or more characters. For that, what I'm doing is I'm setting this particular case is empty character wala case. uh, Empty character, and this particular case greater than equal to one character. Okay, what I will do, I will do simply JSP1. Listen, this particular line, what this particular line does is, this particular line says that the star has started consuming characters, and it has consumed one character, that is the ith character, and I am keeping j as it is, because the jth character is star, and star has started consuming characters. It has consumed one character, and I have set it as one. I need to make some changes in the code. Let me make those changes, and then I will explain how our code is working. So this, if started is 0, then simply these particular cases, simply if started is 0, that means we have not started consuming characters. That means I will get into this part of the code. I will simply check this particular these cases, and I will do things accordingly. If started is 1, now if started is 1, that means I have already consumed one character. And again, if I get into this portion of the code, what I will do is I can either stop consuming characters. For that what I will do, if I stop consuming characters, I will do j+1. Okay, and I will set started to 0. If I want to consume more characters with the help of star, then what I will do, I will do I+1. I will keep j as it is. I will keep it as 1 only, since I am consuming characters continuously. Here the first character is consumed by the star, and here what I am doing is I am saying that it's enough, and I don't want our star to consume more characters, and that's why I have shifted it to j+1. Okay, here I have I had explained it to you. That is, if I am here and here, and I want key this particular star consumes no empty character, then I am doing j+1, and I am keeping I as it is. This is this particular case. Okay, this, and if it happens that I reaches to n and j reaches to m, I reaches to n, j reaches to m, then simply I will return 1. What this denotes is I have started performing operations. Okay, and now I have reached the end of both strings. That means I have found a valid sequence of operations that I am performing on p, such that p is getting completely converted to s. If this is the case, I will simply return 1. If it happens that j is equal to j, let's say, yes, j is equal to m, then what we will do, if j is equal to m but I is not equal to n, that means if I have something like this, something like let me use here something like this. If s is equal to abcd and p is equal to a star b, let's say this, and I am the j is somewhere here, j is here, this the pointer j is at this position, that is end of string p, and I is somewhere here, let's say. So now there are no characters remaining in p with which I can start matching these characters. So that's why if this happens, then I will simply return 0, because uh, there are no characters now in p which we can further use to match them with characters from string s. That's why I will return 0. But if I is equal to n, that is let's say a b c d and a b c d star star star, something like this. If I is equal to n, that means I am here. I am here. Where? This. Here. I am here. I is equal to n. That is I am at the end of string s. Okay. So what in that case what I will do is I will see where my j pointer is. If the j pointer is somewhere here or somewhere here, I will see if all the remaining characters from j to the end of the string p, if all those characters are star, simply I can replace all those characters with empty character, and then our string p will match with string s. That is, if I is equal to n and j is pointing somewhere in string p, and if all the characters starting from j to m minus 1 are all stars, then I can replace all of those characters with empty character, which will result in p being equal to s. Okay, but if it happens that here I have question mark and my j is pointing somewhere here or here let's say I have a and j is pointing somewhere here, and I is here. So if j is here, then though these stars will be replaced with empty character, but still we are remaining with the character a, which is which can't be matched with any character in string s, since we are at the end of string s. So in that case I will return 0. So simply what I will do is I will run a loop int k is equal to j, k less than m, and k plus plus. If I found some character for p of j is not equal to p of j not p of k is not equal to star, then I will return 0, else I will return 1. Okay, so this is finally the code, and here I will return 1, return answer. So what I am doing here is you might be wondering why I am doing or here, because here I only need to find if there exists a particular sequence of operations where I can transform this p to s. If there exists any sequence of characters, simply return true, and that's why I am using or, because answer can come from here, come from here, come from here or here. Okay, that's why. If the question would have been find the number of ways of converting p to s, then what I would have done, I would simply used plus equal to everywhere plus equal to, because I need to add all possible ways, so that's why. So this is the code part. Let's see if it's working fine or not. Then I will discuss the time complexity of it, and finally the dynamic programming solution. Let's see if it is working fine or not. Okay, it is working fine. So now what is the complexity of this code? The complexity of this code is, you can see, exponential. How exponential? Because at every ij, in the worst case, f of ij is making call to making two calls. Similarly, you can see here f of ij is making two calls, here two calls. So in the worst case, a function is making two calls. Okay, and the number of states are ij, that is I is n, j is m. So approximately, and at every stage we are making two calls. Okay, so time complexity would be exponential, and it will be around uh, if we say the time complexity is exponential, that is enough. But if we want to go deep into it, then time complexity will be something like 2 to the power n cross n into m, because at every point we can have two function calls. At every point, two function calls. You can see here two calls. I'm considering the worst case. Okay, so time complexity would be exponential to the power n m, and so this will give TLE. Okay, this will give TLE, so we need to memorize it. uh, for memorization, I already told we have 4 steps. First one is create DP array, then initialize, then do the storing part and returning part. Returning part is if that particular state is already being calculated, we don't need to dive into the recursion tree. Okay, we can simply return if that particular state is already calculated and stored in the DP array. So here now, what will the dimension of our DP table? So you can see here we are having 3 variables changing: I, j, and started. I can take values from 0 to n minus 1. J can take values from 0 to m minus 1, and started can take 2 values, 0 and 1. So the size of our DP table will be n cross m into 2. So let's define the size of our DP table. DP m here I have 2. I am initializing it with -1, and I already told key we use for initializing a DP table, we use such a value which can never form the form our answer. Since our answer would either be 0 and 1, so -1 would never be our answer. So we can initialize our DP table with -1. Basically here DP of I, j started is denoting what I, j started is. If it is -1, then simply it is not computed. Okay. If it is not -1, then what it is telling is, for ij0 it is telling if we can transform string s from 0 to n minus 1 and an string, we can transform string as not string p from 0 to m minus 1 to string p to string s from 0 to n minus 1 if if started is 0, if star has started to consume characters from s, if has not started. Okay, similarly dp of ij1 will denote has started consuming characters. Okay, so now I will pass the DP array here. I will pass it by reference so that only one copy is created. Okay, I will pass DP here. I will pass DP, 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 DP. Then I will see into the DP table if DP of ij and started is already calculated or not. If it is already calculated, I will return it from here only. If not, I will return it from here. Okay, this is the DP part. Let's see if it is working fine or not. If there are some typos, we will resolve it. Okay. I need to comment out this. Uh, where is the error? DP of and okay, yeah, yes, working fine. Let's submit it, and then I will discuss about the time complexity. Okay, it is getting accepted. Okay, so now let's discuss the time complexity. So for the time complexity part, I have already told how to compute it. For time complexity part, see the number of DP states into time complexity per state. Okay, so number of DP states here is n cross m into 2 for that started variable, and time complexity per test case. Here at max we are making two function calls. Okay, two function calls. So time per test case is 2. So overall time complexity is order of 4 into n into m, which is approximately equal to order of n cross m only. So this is the time complexity, quadratic. Okay, so this is the dynamic programming solution. I hope I did my best to explain it. So okay, that's it.